this, put it up there, let me close that out. Let me, I should be able to look. Okay. So, we've covered greatest common factor, and we've covered difference of perfect squares. Do you have any questions about either one of those?
Nope.
Okay. There's a third one, and this is the hardest one and the most important one. And that is where you have a quadratic, and let's take an easy one. Let's say I want to factor that. Okay. Well, the secret is what two binomial terms would multiply together to give you that quadratic. That's what you have to answer. Okay? And there are, this is like a week-long subject, so we're just going to be able to touch on it tonight. But I'm going to teach you my method. Because first of all, I'm not sure which method they've taught you. It could have been the California method, it could have been the diamond method, or it could have just been the teacher's method. I'm going to teach you my method, and it's because I think it's the easiest. Okay?
Okay.
If you'll just bear with me and learn my method, you'll learn why it's so easy. Step 1. Split up the x's. How does that x squared get split up?
Just an x.
X there and x there. Step 2. Figure out both signs. In other words, this needs to be a plus or a minus, and this needs to be a plus or a minus. Well, what do they have to be? You can actually figure it out by looking at the quadratic, what these two signs have to be. First of all, how can I produce a plus 10? If the signs were opposite, in other words, if one was plus and one was minus, I'd never get a plus sign in front of that 10. It would always be minus, right?
Yeah.
So, this plus sign tells me that the signs have to be the same. They have to either both be negative or both be positive. And if I want to know which one, look at that sign. That tells me they both have to be positive. So that's step 2, determining both sides. Okay? Step 3 is actually pretty simple. It's factors of 10 that add to the number 7. Well, tell me what factors of 10 add to 7.
They don't?
No. What you need to do is think about all of the factors of 10. Well, there's a bunch of factors of 10. There's 10 times 1. There's 5 times 2. That's actually it. That's all of it. Well, which one's after 7?
Oh, 5 and 2.
Yeah. Now, let's do the reverse, because that's what factoring is. It's the reverse of multiplying. Remember how we multiplied these two? We FOILed it, right? So I would get x squared plus 2x plus 5x plus 10, and that would simplify to x squared plus 7x plus 10. Well, that's what we started with. That's all factoring is undoing the multiplication. Okay? So, the third step in very, very simple ones, like the one I've given you, is factors of the constants, because that's what the plus 10 is the constant, that add, because the plus sign in front of the 10, to the middle coefficient. Okay, on our simplest factoring problems, that's always what we're going to do. I'm going to give you a couple of other real simple ones. I want you to go through these 3 steps. You think for a moment. That's x squared plus 10x plus 9. Do step 1.
It would be x and then
Remember,
plus.
after you've done step 1, these two have to multiply to give you that.
Yeah.
That's
Okay.
So step 1 is fairly straightforward. You're splitting up the x's is what you're doing. And there's not that many ways to split up the x's in these simple ones. In other words, if you're looking at an x squared, there's only one way to split up that x, and that's x times x. If it was x or 2x squared, then it might be 2x times x. But you got to split up the x's is always the first step. Okay?
Okay.
It's the second step. And it's the end.
It would be x plus on both sides.
And the third step. What are factors? What's the constant?
9.
What are factors of 9 that add to the middle coefficient, which is 10?
9 and 1.
There you go. And then if you multiply these back together again, you get x squared plus x plus 9x plus 9, which gives you x squared plus 10x plus 9. In other words, you always got to get back to that. Never forget that what factoring is unmultiplying. Now, let's take an extremely similar situation. I'm only going to change one thing. Instead of plus 10x, I'm going to make it minus 10x plus 9. How's that fact?
So then it would be x minus?
Yeah, both
Both
signs.
sides?
What do both signs have to be?
The same.
Which means they got to be minus, because the sign on that middle term is a minus. So it has to be minus, minus. Okay? Now, the rest of it is still the same. In other words, factors of the constant that add to the middle coefficient, it's still 9 and 1. And that works. That's going to produce x squared minus x minus 9x plus 9, which is x squared minus 10x plus 9. Okay, you with me?
Yep.
Okay, now we're going to take it up a notch. Well, how much time do we have left? Can you give me 2 more minutes? Because I missed 5 minutes by having to reboot my computer. So this is the easiest situation that I've just given you. And what makes it the easiest situation is that it's just x squared. There's no number in front of the x squared. If I put a 2 in front of the x squared, automatically becomes harder. Okay? But I want to get through the easy ones right now. First step.
X.
Second step. How can I produce a minus 10? What do the signs?
It would have to be a plus and a minus.
Yeah, they have to be opposite. And it doesn't matter whether I put the plus on the left and the minus on the right or opposite. So the only thing I know for sure is they have to be opposite. Okay? And that changes the rules a little bit for step 3. So step 3 is factors of 10 that don't add to the middle coefficient, but subtract because of that negative sign. So what factors of 10 subtract to the number 3?
5 and 2.
Okay, perfect. So we know 5 and 2, but now we got a fourth step. We got to know which side to put the 5 on and which side to put the 2 on, because it makes a difference. And the answer is, take your biggest number, 5, and put it with the sign of the middle term. The middle term has a plus sign on it right there. So the 5 goes with the plus, the 2 goes with the minus. And now if I were to multiply these back together again, I get this, which simplifies to this. In other words, you always got to get back to what you started with. That's what factoring's all about. And like I said, there is no skill in algebra more important than factoring. We're liable to spend a whole nother session on it. I want you to be able to get good at factoring, at least on easy level factoring problems. And what I call easy is when that is a 1. In other words, when what's in front of the x squared term is a 1. If I had a problem like this, that's mucho more difficult. And I mean mucho, a lot. Okay? So, but I don't really care if you can master that. I don't think you're going to have to master that when you take this test. That's Algebra 2 more than Algebra 1. So my guess is that the only factoring you're going to have to do is for problems like that, where this coefficient in front of the x squared is always a 1. And if that's the case, then factoring is really easy. And you don't have to worry about these complicated factoring systems that they teach you in school. Not necessary. You can do 90% of the problems with my real easy 3-step or 4 steps at most method, as long as there's a 1 in front of the x squared. And that's all we're going to want you to master for now. Okay? like I said, anything beyond that is more Algebra 2, not Algebra 1. But if we can get you to be able to factor all easy quadratics, and that's what that's called, is a quadratic, you'll be in great shape. Okay? All right, Phoebe, that's a good place to stop. What did we get to? We got to factoring. So halfway through number 3. All right, that's good. Phoebe, I will talk to you next time.
Yep, sounds good.
Sorry for the difficulties tonight.
Yeah.
All right, bye-bye.
Bye.